electric field, electric field due to a charged disk. Now earlier it was a ring, now it is a charged disk. Electric field due to a charged disk at a distance r from the center of the disk. Center of the disk. Now see, the thing is, the disk is something like this. This is something like this. The whole thing is there. I am asking you, this is the radius r of the disk. From this center to this point r, I want to find the electric field at this point. We will consider an elementary part of the disk. Let's consider this much elementary part of the disk of thickness. You see, this much. Wait a minute, this much. Let me draw the figure little big so that you can understand the thing completely. Let's draw the figure little big. This is your disk. This is completely filled, basically. This is the center of the disk. This is of radius r. This is of radius r. And you want to find the electric field at this point P, which is at a distance r from the center of the disk. This is the point P. This is the point P. You can take it this way. Now you consider an elementary portion of the disk. Elementary portion. This much you consider, and then you consider this much. Okay. Let the radius of this much portion be rho, and this much thickness, I'm talking about the thickness of this much, thickness of this much is d rho. It's very small quantity, d rho. This rho is different from, do not confuse this with charge per unit volume. Don't confuse this with that. This is because we have only 23 Greek alphabets and we have got a lot of symbols. So now you take this much portion of the disk. From here you consider a elementary portion of this disk, and from here you take the electric field to this point. This is making an angle theta here, no problem with it. This is using Pythagoras theorem. If you use the Pythagoras theorem, this is r square plus rho square. Rho is here the radius of the elementary portion of the disk. I'll write everything. Consider the y-axis, and this is your x-axis. So this is your theta. This is your dE1 due to the upper portion of this elementary portion. This much portion. Let me draw this. This much elementary portion you are talking about. This much elementary portion that you are talking about. This is that electric field due to that portion. Similarly, if you take a little portion of this much part, you will again have like this portion in this format. This is called a dE2. Magnitude, they are both same. This is also theta, so this will be theta. This is your y-axis and this is your x-axis. Now again, wait a minute. This is the radius. Radius is here. Sorry, the distance r is this, and this much portion. This is r square plus rho square. This is the thing, basically. Now see, let us now write the whole thing. Consider an elementary portion. Just a minute. Elementary portion of the disk. Of radius. Let me write here. Radius rho and thickness d rho. Right? The disk, the complete disk, the full disk, the disk. When I talk about disk, I'm talking about the complete disk. When I talk about the elementary portion, I am talking about this much portion. Only this much. The disk is of radius r. Right? Now, the upper part, the electric field, let me write electric field due to the upper portion of the disk, upper portion of the elementary disk, or portion of the elementary disk of the elementary disk is DE1. Now, so DE1 is nothing but DE1 cos theta I cap plus DE1 plus sin theta minus j cap. So this comes out to be DE1 DE1 cos theta I cap minus DE1 sin theta j cap. Now, similarly, from the lower portion of the disk, similarly from the lower portion of the disk, the lower portion of the elementary disk, the electric field is electric field at the point P. This is also at the point. Electric field due to the upper portion of the elementary disk is DE at point P. Let me write at point P. At point P. The electric field at point P. At point P is, let's write, is DE2. Now see in the figure. Let's see in the figure. This DE1. This will have DE1 cos theta component here, I cap, and this will have DE1 sin theta component J. Similarly, this DE2 will have another component here. Let me write it with a different color. For this one, I'm talking about this one, it will have DE2 cos theta I component, and you will have DE2 sin theta J component. Now this component would be there. Now see, so now DE2 is DE2. So DE2 is nothing but DE2 cos theta I component plus DE2 sin theta J component. The component from the upper end and the upper portion and the lower portion, that is DE1, scalarly they are both same, DE2. This can be said equal to DE. This is nothing but 1 by 4 pi epsilon naught sigma dA. I'll just explain this. Sigma dA upon your, this is rho square plus small r square. This is, now what is this sigma dA? Now dq is nothing but sigma dA. What is sigma? Sigma is the charge per unit area of the disk divided by this. Now what is this dA? dA can be written as rho d theta into d rho. Why? Now you see in the figure. In this figure, you have taken an elementary portion of the disk like this. You have taken an elementary portion of the disk like this. This was the elementary portion. The thickness of this, I told you, is d rho. The thickness, and this is d theta, and this is rho. This length is rho d theta. So the area is length into breadth. This is the length and this is the breadth. So the area is this way written. This is, let me write it little clearly, this one. This is d rho, the thickness of the elementary portion. This is the thickness of the elementary portion, and this is the which is basically the breadth. The thickness is the breadth, and the length of this much portion is rho d theta. Now this is the way you need to write. Now the point is, let us now calculate the net electric field. The net electric field at point P. Net electric field at point P. We need to find the net electric field at the point P. Now you see, this is DE. Vector is DE1 vector plus DE2 vector. What is DE1 vector? This is nothing but DE1 cos theta I. Then you have minus DE1. So instead of writing DE1, let me write it DE, because we have taken here. See, this we have taken. The scalar value is all same. The scalar value is all the same. See, this scalar value is all the same. So let us, instead of writing DE1, let us write the scalar value as DE. No problem. So now we will write this as DE plus DE sine theta j plus, for this component, for this it was this. For this component we have DE cos theta I plus DE sine theta j. DE sine theta j. This is for this component, the second component. Now they and they cancel out each other. So DE is now equal to 2DE cos theta I component. See, in smaller classes, especially in class 12, you used to write this. See this figure. If you see this figure, that this component is going to cancel out with this component. We used to write this. The vertical components cancel each other. Instead of writing that cancellation, you can do it in a vectorially. They automatically will cancel out mathematically only. Vectorially or mathematically, what you want to say. They will cancel out. Now let us put the value of DE in this. Now see, DE is equal to 2 into 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught sigma dA upon rho square plus r square. Cos theta is what? What is cos theta? You can see cos theta from here. From the figure, you can see cos theta. This is your theta. This is your theta. This one is your theta. Cos theta is base upon perpendicular. R upon r square by rho square. Now you can write that. So here, this you can write into r upon under root rho square plus r square to the power of 1 by 2. And this is I cap. Now you do one thing. DE, now you don't know what is DA. I just told you DA is rho d theta d rho. D rho. So this can be written as rho d theta. No problem. So 2 into 1 by 4 pi epsilon naught rho, then you write as this as rho d rho sigma d rho d theta upon r square plus rho square to the power of 3 by 2, and this r, let's write it here, and I. Now let's do the integration. After integration, this becomes this 2 into 1 by 4 pi epsilon naught. Then you have your sigma r here, no problem. Then you have your rho d rho upon r square plus rho square to the power of 3 by 2. Since this is d theta, you write it d theta here and take an integration. Now see, you took a disk. Now you took this much portion of the disk and you took this much portion. The contribution from these two portions will be coming from both the upper half and the lower half. So it will be 0 to pi, not 2 pi. If you write 2 pi, you will be double counting this portion again, the way I told you earlier. This will be a double count, so you have to take 0 to pi, not 0 to 2 pi. You have to take 0 to pi. If you take 0 to 2 pi, it will be a double count. Do not take 0 to 2 pi. Just keep it pi. Do not take 2 pi. If you take 2 pi, it will be a double count. You have to avoid the double counting. Now let us try with this, and this will be from 0 to r. Now let us do the integration. E is now 2 into, don't cancel anything right now, 4 pi epsilon naught sigma r, this is sigma r, now 0 to r rho d rho upon r square plus rho square to the power of 3 by 2 into pi. So bring this pi here. This is I cap. I forgot to write I cap. This I cap must be written along with it. Vectoral form must be kept. Now E is 2 into 1 by 4 pi epsilon naught sigma r pi you take, and then you have 0 to r rho d rho upon r square plus rho square to the power of 3 by 2. Now this is I cap. Now you do the substitution as you do in definite integrals. Let t square rho r square plus rho square equal to t square. Now you do, this will become 2 rho d rho is 2t dt. Now this and this 2 will cancel. So E vector will be equal to 2 into 1 by 4 pi epsilon naught sigma r pi upon now at 0, at rho 0, this will be r, and at this it will be r square plus rho square, r square plus r square, capital R square, small r square plus capital R square under root. And this will be p dt upon t cube I cap. I hope you understood. Put here 0. This 0 you put here. Then it becomes when r is 0, then t square equal to r square. So t is equal to r. So this r has come. Now when you put in place of a row, you put this r. Then it becomes when r equal to r. Not r equal to 0, but this is actually rho equal to 0. You have this. When I made a mistake here, this rho is 0. When rho is 0, then when rho is 0, I was saying that only, but I wrote my mistake. I wrote r. When rho is 0, you have t square equal to r square, t equal to r. So at rho, not r, but at rho, when rho is r, when this rho is r, then you have t square equal to, from here you have r square plus r square, and t is equal to under root r square plus r square. I hope you understood this part. Now this cancels out with this. So now what you are left with, electric field is now, the electric field is 2 into 1 by 4 pi epsilon naught sigma r pi. This is you have got. And then what you have got is this, see. This you have r, this you have under root r square plus r square. Then you have got dt by t square I cap. Now the integration of this is, you already know, because already know this integration. This will be 2 into 1 by 4 pi epsilon naught sigma r pi, and this will be minus 1 by t. The integration will be this. The lower limit will be this, and the upper limit will be r square plus r square. And then you have I cap. Now when you put the upper and the lower limit, so now since the minus sign is there, let's see, 2 into 1 by 4 pi epsilon naught sigma r pi. So what you have is, first you write this minus 1 upon under root r square plus r square. Then it is plus 1 upon r I cap, because of this minus sign, the minus sign here, because of this minus sign. Now what you do is that, cancel this 2 with this 2, pi with this pi. What you are left with, E equal to, now see, sigma r by 2 epsilon. You can write 1 by r minus 1 by r square minus r square I cap. Now take the r inside. So E is equal to sigma by 2 epsilon naught. This r will cancel with this r. 1 minus r under root r square plus r square. And this is I cap. Now at the center of the ring, center of the disk, sorry, not the ring, but disk. At the center of the disk, r is equal to r. R is equal to 0. Since this is 0, the electric field comes out to be, this portion will become 0. This will become sigma by 2 epsilon naught. And sigma is nothing but q upon pi r square. 2 epsilon naught pi r square. This is also one such, and this is in the direction of this I. So, and suppose now at r equal to r, at this r equal to r, what will happen? See, E will become sigma upon 2 epsilon naught. This will become 1 minus r upon r2r square I cap. Now see what will happen. This is r square. This term is square in the under root. See what will happen. E will become sigma upon 2 epsilon naught 1 minus 1 by under root 2 this, there will be an r here, and this r will come. These two r's will cancel out each other. So E will become sigma upon 2 epsilon naught 1 minus 1 by under root 2. That is I. This will be the value of at r equal to r.